my friend. Yep, perfect.
It's over there, Jim.
So, it's still over there? Alright, so. Fuck off.
I can see you now too.
Spell backwards.
James, this is live.
Oh. So we're at Facebook Live now, so apparently
Okay.
there's Facebook Live on this one, and then you're on this one. So I can stand kinda here and everybody can see me. But if you actually spell F word off and then spell it backwards, it's the same thing but with a British accent. So just say it backwards for anybody on Facebook Live. We don't want to get banned.
Oh,
So
Facebook jail.
yes. So where should I go? I'm gonna go to Facebook Live. So this is
Right there is great program.
okay. This is the Area 51 chapter of ACA.
No.
Oh, what?
RSES.
RSES, sorry, my fault. RSES.
What?
My apologies. And, you know, it actually says right here too, I watched it 14 times. It was like right in front of me. I apologize. For that
Don't
too.
know anything.
There we go. With us today from vacation in Peachland,
British Columbia.
British Columbia, is Tim Prevost. Tim Prevost is the Director of Business Development for High Velocity Systems. High Velocity Systems is the brand of high velocity product that Len Myers and Associates represents. And he's gonna be covering about an hour, hour and a half, taking any questions at the end or during about his system.
What country is he in?
What's that?
What country is he in?
He's in Canada right now. So High Velocity Systems is actually a Canadian brand.
Okay.
So he's our North American neighbor for anybody geographically impaired. Without any further ado, Tim, take it away, buddy.
Oh, thank you very much, Jim, and thank you everybody for tuning in off the live stream, and for those in attendance at the office there. Really appreciate your time, and I'm excited to show you the type of products that we have to offer, as I feel it is very unique in the industry, and the solutions that our small ducted system can provide for our installers, for our builders, and as well for the end user really outweigh what you can achieve with conventional forced air products. So I'm excited to show you that and letting you know a couple things about our company. I did, in earlier conversation, we were talking about maybe other high velocity brands like Unico, where those companies focus heavily on retrofit into existing structures. 95% of the business that we do as a company is new construction, whether that is your high-end custom, your row housing multifamily, or even your large commercial structures in either the warehouse world or the agricultural grow world. We have a very diverse solution of products we are able to fit in to virtually any type of application and project. So just I like you to think a little bit outside of the box, where people might think a small duct system like this is only used in retrofit. Most of our business is new construction. To help understand the advantages of what this product can offer you and your projects, I want to explain the difference between a conventional forced air duct system and a high velocity duct system. Now, it revolves around the fan law, where you convert pressure to velocity. And with conventional forced air, this happens at the fan cabinet. We're then designing the duct on 0.1 to 0.5 inches of static pressure. But because of that lower velocity, we have to continually reduce the duct to try to squeeze that air to the furthest reaches of your duct system. And trying to achieve a balanced airflow out of every register in conventional forced air is extremely difficult, specifically in longer duct applications in your custom build world. And trying to trick the air with balancing dampers and booster fans really can be a bit of a nightmare on some of these large projects. Now, by the time the air reaches the furthest reaches of that duct system, it's at such a low velocity of determination that we're trying to diffuse the air in multiple directions in the hopes that by doing so, we're going to instill that proper mixing of the room air. I didn't mention already, but my company actually also manufactures conventionally ducted fan coils for conventionally ducted applications, whether it's a furnace replacement or a fan coil spec off commercial sites. We do a lot of that as well, but there's so many advantages to the high velocity duct system. You'll see that that is a focus of our marketing and my presentation today. But being that we do manufacture conventional forced air products, we do a ton of testing on A versus B. And with that conventional forced air, we're always dealing with lazy air. We're always dealing with stratification of the air, warm air rising, cold air dropping, which is why always on high ceiling applications, we need a ceiling fan to try to get the heat off of the upper echelon of that space and try to achieve even temperature from floor to ceiling and from room to room throughout your project. It's also why it's so critical with conventional forced air to supply air on one side of the room and return air on the other, in the hopes that the return air draw is enough to get those heated, cooled BTUs mixed throughout that space. With a high velocity system, instead of operating at 0.1 to 0.5 inches of static pressure, we're operating around 1 inch, 1.2 being the maximum that we designed for. Now the physics of air at 1 inch of static pressure change. They become much more like the physics of a fluid. And our duct design much more mimics a hydronic piping design than a traditional air design. You never have to reduce the duct on a high velocity system because we're maintaining an equal consistent static pressure from end cap back to fan coil, giving us equal airflow to all of the outlets on our duct system. Even if you're running a plenum 100 feet away from your air handler, you should have less than a 5% CFM variance from the first outlet to the final outlet on your duct system, which now gives us numerous advantages on the ways we can run plenum duct through structures, not having to worry about that loss of airflow at the furthest reaches of your duct system. So these are advantages to our builders, with the smaller duct being able to hide up in spaces, and to our installers being able to run that duct in more trick locations without having to worry about loss and system performance. But the advantages now that we're offering to the end user is what happens when we convert that pressurized air to velocity at the termination point, and what moving proper airflow in your structure can do to the comfort level, but also the air quality level by moving air more effectively. We all live in homes where when you open up the windows and the sun shines in, you typically see millions of suspended particles in the air. And that's a measurable thing with a laser particle counter. And I love taking my laser particle counter out to sites with high velocity and showing the measurable difference of particulates in the air by moving air more effectively with a product like this. Now, how that works, as the air is coming out of our outlet, it's actually drawing in the room air and forcing total circulation through either a combination of Bernoulli's theorem and the Venturi effect is how that happens. To explain that in a simplified term, as the airflow comes out of our register at approximately 1,200 feet per minute, it's displacing all of the air molecules around that outlet, creating a low pressure zone. Any air that's at a higher pressure than the low pressure zone will be drawn in and forcing that total mixture, just like a weather system and just like the weatherman telling you the storm is going to be drawn to the low pressure area. We're virtually creating our own indoor weather system as HVAC people, and that low pressure zone is amazing to see how much it circulates air better within a space. And then the advantages we have now on locating outlets in more low traffic areas, not by the windows and doors. I'll show you some of those advantages as well a little bit later in this presentation. Ultimately, though, with a high velocity system, the way that we're moving air more effectively, you can literally put a thermometer on the ceiling, a thermometer on the floor, and see less than a degree of difference. This is what the air looks like coming out of one of our 2-inch high velocity outlets. Please note that this outlet is actually located on an inside wall right near the door, where typically you would locate that all the way to the outside wall of a structure. And even with that outlet being on an inside wall, over a period of 30 to 40 seconds, we have total floor-to-ceiling interaction with the conditioned air entering that space. So now we're thinking about temperature and the mixture of the temperature within that space, even with the absence of a return air in that room. But what it does in the ability to move air, clean air more effectively with something like a denser filter, MERV 13, or an air purification system is the big selling feature on this product today, and why we are in some of the most high-end builds in the world right now, because of the proven difference of air quality that you can achieve within your indoor structure. Because of that pressurized plenum duct, we have flexibility with our mechanical placement. We don't have to be the central air handler, which was typically dictated due to the fact that we wanted to keep our duct designs down to a minimum and prevent that starvation of airflow on the furthest reaches of your duct system. We can move that mechanical location out of the central expensive square footage of the build and move it to a more unused location of that build, now opening up the central square footage on a new construction build for other cosmetically or architecturally appealing decor that might help sell these homes. Now, I said earlier, you don't ever need to reduce our duct size, but you can if it's advantageous to do so for a cost-saving or a space-saving measure, but you never need to reduce the duct system. Here shows one of our installations on a commercial build in a basement, and it shows my air handler in a vertical lift with a return air base underneath it and a chilled water, hot water, 4-pipe solution. This was a commercial building rehabilitation facility, and due to the living arrangements for injured servicemen in this rehabilitation facility, we decided to micro-zone the air handlers and put a thermostat in every individual room. So every one of these air handlers has 6 to 8 zones that it takes care of independently, and the chilled water solution was very important to having that type of micro-zoning and airflow manipulation, where DX cooling typically would struggle in that type of application. We do approve our units to be installed in unconditioned areas like crawl spaces or attics, but you do have to follow some specific criteria for attic spaces, secondary drain pan underneath the product, insulating to code your duct system, and in some markets, our customers will even insulate the equipment. This air handler on the left is from the Jersey Shore, and the amount of excess humidity in their summer applications, they like to insulate that cabinet because it could reach dew point and potentially drip. So insulating, critical factor on that type of unconditioned space. Although in new builds not practiced regularly, I do this in retrofit where there is no mechanical room within the structure that we can access. Every unit I manufacture on high velocity or low velocity fan coils are multi-positional. We don't sell vertical and horizontal options. Every unit we sell is multi-positional out of the box to really fit the diversity of the mechanical space that you have to deal with. I do like to promote to my guys though, why run a return air drop to a unit on the floor and a supply air and take up the whole wall when you can take that same equipment, install it horizontally, and open up all of that wall space underneath it for your reverse osmosis, humidifier, of HRV, whatever other items you might need to fit within that mechanical type space. Off of our air handlers, you start off with either an 8-inch or a 10-inch diameter main plenum duct, of which I typically suggest spiral ducting due to the simplicity of the installation and sealing that duct. But absolutely, you can use snap lock ducting. You do have to pay attention to snapping in that seam and sealing that seam properly with our high pressure duct system because actually the sealing of the plenum duct might be one of the most important factors on your installation. With a high pressure duct system like this, if there's a place for air to escape, it's going to find it and it could potentially create an issue. So even with adjustable elbows, you don't just seal the inlet and the outlet, you do need to seal the adjustable doors as well. And sealing is a critical installation factor. You're going to see pictures in my presentation like this where these are uninsulated duct systems, and a lot of my multi-family projects up here in Canada and even some northern US, they don't insulate the plenum. I would imagine in your market, being right near the water, that would probably never be practiced. I do promote insulating the plenum duct in my drier market here, not always practiced. Strong recommendation, as I can ensure adequate airflow 100 feet away from the air handler. I can't necessarily ensure adequate temperature of air 100 feet away from the air handler if we're allowing the energy to radiate out of the duct system. A couple of very important laws on the install and design of a high velocity plenum duct. We always want to try to achieve 18 inches of straight duct off of the unit before elbows, tees, and takeoffs to obtain proper uniform velocity for the most effective performance and efficiency on this system. Sometimes that's not 100% practiced, but we do have variable speed blowers now where we can dial up the static operation to overcome such restriction. But a very important law is the balancing of tees on a plenum duct. I have no problem with you coming out of the air handler and running 100 feet with 13 elbows in it. Really doesn't affect my performance. But if you came out of the air handler split into a bullhead tee in two directions, and if you have 3 outlets on one side and 30 outlets on the other, you will have an imbalance of airflow. So if you're using tees, you need to balance the tees with the bullhead, try to have a 50-50 split in each direction. And if you're just pulling a branch off of the main plenum, that branch can feed a maximum of 30% of the vents versus what continues in that main direction. But it is common to take a branch off to feed 3 outlets, take another branch off to feed 2 outlets, and then continue in that main direction and utilize multiple branches. When it comes to return air, very specific to the size and amount of return air I need, but not to where it gets installed within the structure. I don't need return air in every room to get the cooling, heating, performance, and mixture. So 90% or more of my contractors elect to go for a central return per floor, as that is more than adequate to get the air quality and heating, cooling performance necessary. In new construction, we often have to specify a 1/2 inch or 3/4 inch undercut on a door or a transfer grill, but nobody really wants pass-by transfer grills anymore, so the undercut is more than adequate. Of course, if local code trumps that allowable, you can put a return in every room like you've always done with conventional. It's just not regularly practiced, as it's not necessary to ensure proper performance with my product. Off of the main plenum is when we now branch off with our patented acoustically lined silent flexible duct system. The flexible duct products we sell in 10, 15, and 25 foot lengths, assembled with quick connect fittings on each length of flexible duct. We do not suggest exceeding 25 feet due to the loss of airflow on longer flex runs. We always try to promote trying to maybe take a branch off the plenum 10 or 15 feet closer if at all possible with a 5-inch or 6-inch duct, instead of running multiples of 25 plus feet of flexible duct. On the reverse end of that, due to the acoustically lined properties of that flexible duct to create a silent operating system, we don't suggest cutting to less than 10 feet. If you only have 5 feet from point A to point B, we ask that you snake the flexible duct to utilize the acoustic properties of that flex duct to create that quiet, silent operating system. If you do cut one duct down to 3 feet, because that's all you need from point A to point B, that airflow could be stronger than all of the others and potentially create a noise issue. When you buy a length of duct from us, from your wholesalers, everything you need to install that duct is in the box, ready to go, so you're not buying takeoffs and boots and outlets all separate and get out the site and find you're missing a couple of items and gotta bring it back in from Canada. When you get that length of duct from us, everything you need in the installation is right there in that box. The takeoff to connect to the plenum. We have a patented rough-in boot that has a built-in shut-off mechanism, so the homeowner can simply spin the outlets open or close to open or shut the airflow out of specific individual registers.
Hey, Tim?
Go ahead.
I just have a visual here that I want to share with everybody. So if everyone wants to take a look at this stack of pizza boxes here. So this is about how big the box is for the flex duct, and everything that was in that previous slide goes in a box about this size. And as you can tell, packaging like this is designed around new construction. So if you are putting in one of these in a new construction, if you're going to have 2 of these in a large living room, you put 2 boxes in there. You put a box in each of the bedrooms. You put one in the closet, one in the bathroom, and then as you're going through the day, all your boxes are pretty much, in the locations where they're actually going to be installed.
Yeah, good point, Jim. And we do have now added on each length of duct on the ends a quick connect fitting. So really the only thing you do when you get out the site is attach it to your takeoff, pop a screw, wrap of tape, you just installed that flexible duct. Very simple, easy, and designed for time saving. We are getting a ton of feedback in residential new construction that our install time is upwards of 30% less than conventional. So that can mean money in our installers' pockets by saving mass amounts of time on site. And as well, if you've ever dealt with maybe competitive lines of high velocity, you might be thinking in your head, how can I get this in new construction? This stuff's expensive. Our product is much more affordably priced than our other high velocity competition. And if we get into projects of 10 or more systems, we do have our Builder Series product line that we're happy to get in and meet the budget criteria to compete with the Yorks, Carriers, Lennoxes out there in that type of residential new construction. So if I was $50 more than the Lennox option, I don't get the 500 unit condo project. So we know how to play that game as well. We have 2 sizes of flexible duct, the traditional 2-inch, and then our patented HE flex duct, which is exactly double the airflow of a 2-inch, now requiring half as many outlets on your site. So where we with the 2-inch product would do 8 outlets per ton minimum, we're now at 4 outlets per ton with the HE. Just about every system we do mix and match both sizes, as the 2-inch is more than enough to meet the heating, cooling load in bathrooms, walk-in closets, mudrooms, etc. So typically we do mix and match. I do promote the 2-inch on retrofit installs, specifically finished wall retrofits where you're trying to snake duct up a finished wall. I do like the 2-inch product for that. Or if you are installing it for a sidewall delivery within 2x4 wall construction, the HE rough and boot won't fit, but the 2-inch does. Now, because of how we're moving airflow more effectively, we have flexibility with where we locate our vents within the structure. So traditional logic would dictate to the outside walls by windows, or at least spread around the room. And if you can do that, great. There's so many times where the architect just reduces the amount of areas we can run duct to. And if we specify this living room needs 4 outlets, as long as they're in the 4 walls of that area, you're going to be able to heat and cool properly. So I'll show you some examples of that. When we're putting our outlets into the floors, I'm basically avoiding one thing when I'm thinking about locating them, and that's furniture. If 2 of my 4 outlets in the living room get blocked by furniture, you will have a performance issue, but you don't need to run these to the occupied areas. You can pick the corners, you can pick by the entry where it's going to be more low traffic locations. Ultimately though, locating them in places that aren't gonna get covered by furniture is what my design team takes a look at when we're engineering projects for our customers. And if you have that ability to communicate that fact to the end user or the general on site, we can locate these anywhere within the room that will be best to avoid furniture. If you want to avoid that conversation entirely, the high sidewall delivery is a very popular way of running the high velocity system, especially in that custom build application. This is home of Mulholland Drive in the Hollywood Hills, famous pop star. All sidewall, just because we had to avoid the exotic hardwoods on the structure and a lot of the crown throughout the rest of the build. This is a high-end home in Tampa, Florida that we did a couple of years ago, and I was lucky enough to get in before and after drywall to really showcase the diversity of this duct system in that high-end structure where bulkheads are absolutely out of the question. Conventional duct is darn near out of the question because of that sole fact. And we can really get in and really provide a quality air system to these structures, not sacrificing cosmetics, which these architects are really tuned into with our product line. In kitchens, we always take a look at the kick plate, but I always try to promote that 12 to 16-inch void that regularly exists above the kitchen cabinetry as a better location to put that duct. I often get questions on the picture on the left, why so many ducts? Well, this is actually Manhattan Beach, California, a great room with a wall of windows facing the ocean, and that little bit of crown molding on the left I had to avoid, and I wasn't allowed to get anywhere else, so the architect gave me this one little area to do 2 tons of cooling for the great room. So even with those outlets being 20 feet away from the wall of windows facing the ocean, we're able to heat and cool that space without any issue because of the way that we move airflow more effectively with this product. Another neat project where this was actually a retrofit for a castle in London, England, and we retrofitted 9 high velocity systems into this existing castle structure without sacrificing the architecture. Another location to put our ducts is in the ceiling, and if you're putting them in the ceiling, the grill itself has a removable center, so it looks, in my opinion, like a hot light. So the schools of thought on a ceiling location are trying to avoid traffic areas and blowing on you when you're sitting on your couch watching sports or on your master bed. So I'm trying typically to go towards the perimeter of a space in the ceiling application. But a lot of my guys will put it in and line things up symmetrically with the pot lights and the speakers and whatever other round architectural decor exists within that ceiling space. Ultimately, though, we're going to tell you how many outlets you need in a room, and the flexibility of where you locate those outlets within that space is 100% up to you and your customers. To try to achieve the best location and the least obtrusive location for your install and for the end user's comfort level. We have different architectural decors available in the metal or wood options. The oak and maple are not stained, so that you can stain them to match and recess within your hardwood floor. And the white outlet itself is that comes standard with the product is paintable, certainly. If you're looking for more of a traditional finish in the grill face, you can do that as well, but as you can see in the diagram we provide our customers, we want that airflow to enter that space as unimpeded as possible. Pretty much the main criteria is that high velocity airflow needs to be delivered properly in order for it to do its job. We don't offer these grills, but they're standard Hart and Cooley EH price grills that my customers typically use out on site in that type of finish. And this is becoming the most popular finish right now. Go ahead.
Is there issues with noise going through those grills like that?
If it's restrictive grill, yes. What we typically try to ask for is straight vein. We don't want diverted we want straight vein, and we want as open as possible. And then we never typically have a noise issue. So that's the criteria we're looking for. But I have been out on projects where they'll use a more traditional wood type of grill that is more restrictive, and that can lead to some sound issues, yes. This type of finish with the linear slot is becoming ever more popular in that custom build world. And I do have customers all over the world that are doing this now with high velocity, and we allow it. We don't have a product today that we can sell for that, but we are very close to releasing our own brand of linear slot solutions, where it will be one continuous slot with multiples of boots being able to slide into that slot for a linear outlet solution like this, which is becoming the most popular request for finishes in high-end straight line architectural builds. Getting into commercial, and a lot of people don't think high velocity in commercial, but when we explain the type of drilled outlet systems that we're doing, the amount of micro zoning we're doing in offices to give every office its own independent climate control, and doing it all through a small duct solution, it can really change your thought process in trying to avoid rooftop units, big bulky ductwork, etc. We're specified in Apple stores worldwide, not for the heating, cooling, small duct, but for the proven air quality that we can achieve by moving air more effectively with our patented air purification system, which I'll get into a little bit later. And what this is, if you're dealing with exposed duct systems, and as HVAC people on this call and in the room that I'm talking to right now, you're probably guilty as I am walking into the pub or restaurant and looking up to see all that exposed duct everywhere, which is typically 20-inch, 16-inch throw-in diffusion grills that are right in the middle of the room blowing on you and you're trying to enjoy a beer. With our product, we don't need to deliver the air to the load areas like you do with conventional. So our exposed duct system is typically a 10-inch or 8-inch duct with 2-inch holes drilled into it. Getting the right amount of holes is where we can assist you. You can't just pop 100 holes, reduce the static. You're going to reduce the delivery of airflow to that operation. Here's a children's play center in Ireland where instead of using metal duct, they use a fabric duct sock product. So we are approved for use with that type of fabric duct sock application, children's play center in Ireland. Here is an ATV sales center in Lake Okoboji, Iowa, where when we got involved, they were really looking to have a better finish and look. This was engineered with conventional exposed duct, and they didn't like the idea of what it was looking like. So we were able to do 5 tons of cooling into this area with one 10-inch duct, spiral duct painted black, and 2-inch holes drilled into it. Very cost-effective way of doing exposed duct commercial type of installations, and in my opinion, from what I've seen result-wise, it will outperform traditional duct systems in these applications any day of the week. And then what we did actually here was pretty neat, because I used one of my new 10-ton air handlers with 2 zones. And I had a 5-ton zone going to the retail area I'm showing you, and I had another 5-ton zone going to the service bay area to just provide them some cooling within those areas. An air curtain, another application for exposed ducts, where in our markets up here in your market in northern US and up here in Canada, when it's cold outside and you open up that bay door to load or unload a truck, you can just watch that heat escape out of your build. And this air curtain is not necessarily used to heat the space, but it's used to keep the heat in the space with an effective thermal barrier. Just another unique application for our product. If you don't have the space for 8-inch or 10-inch duct, you can absolutely pull a ductulator up and convert that to rectangular or oval ducting. You just have to find the same volume of duct that you were utilizing from the round. And I use this typically to get by restrictions within my build, but I've had some recent builds that are so highly restrictive. For example, we were engineered onto a project that required 13 tons of cooling for a penthouse apartment, and the engineer gifted us with 6 inches of space to do 13 tons of ducted air conditioning. And I believe, if I remember, that it was a 4 by 20 duct insulated that we were able to fit up there, which is equivalent to a 10-inch duct. So if you do have that highly restrictive project for ductwork, this is your solution that we can come in and help you with. With the AC coils that we provide with our product, they're unique in the sense that they sit on the return air side of the air handler. You can't just take an A coil and pop it on top of the high static side of our duct system or create waterwork issues all over the place. Our draw-through coils as well do 30% more latent cooling than traditional AC. So if you're looking for extra dehumidification, more comfortable air in your air conditioning season, and a more comfortable feel of air in your home and structure, that extra dehumidification makes a world of difference on the ultimate comfort level to the end user or occupant. And something I'll get into a little bit later as well, getting into the agricultural indoor grow world that is exploding throughout North America right now. Our 30% dehumidification capability with this product is a massive selling feature, because that is the biggest issue they have on indoor grows is overhumidification and products that don't dehumidify properly. My RBM series cooling coil comes with the TXV built in. It is an adjustable TXV. It also comes with freeze protection sensor that we mount to the suction line and run to my board. So if the coil were ever to be exposed to a freeze up situation, it will open up and kill the outdoor unit while it unthaws itself. The RBM coil is designed to sit underneath the air handler, but as I've already said to you, every unit is multi-positional out of the box. That exact same combination of product can absolutely also be installed horizontally. Getting into hydronic heating, which is the predominant source of heating for my products up in northern US and Canada. That 6-row coil that we provide on both my low velocity and high velocity fan coils is a massive difference to the traditional 2-row coil and makes us very much compatible with the low GPM tankless products out there. So a high percentage of my new build with residential new construction, multifamily and condos is hot water hydronic heating through my 6-row coil. In some buildings, that's a central boiler. In our row housing application, it's something like a tankless, some sort of tankless water heater that's doing the domestic and feeding my 6-row water coil within my fan coil as well. I do chilled water options. A lot of times geothermal is chilled water when I'm doing geothermal on some builds. The chilled water coil is that same 6-row coil, which again gives us better BTU outputs at the poorer entering energy water temperatures. Getting more popular now is all electric solutions for net zero off the grid applications. Last year, I did over 300 net zero builds throughout North America. We're we have a very good, efficient solution for all electric projects, utilizing typically our low temperature heat pump in conjunction with some sort of electric strip that we offer, and we do offer that in different kilowatt capacities from 5 to 23 kilowatt, and we offer that now in a fixed capacity or modulating electric strip if you're looking for efficiencies on that all-electric type of solution. I often am using this electric strip to be the backup for geothermal applications, because we got to remember that a geothermal system still is a heat pump, still is limited to lower ambient operations, and needs some sort of backup heat typically as well. Due to the code requirements of HRVs and ERVs, we now see that on almost every new build and construction that we're doing. You do not need to independently duct the HRV, ERV into your system. You've already got the high velocity ductwork throughout the structure. So most of our contractors elect to put that HRV and install it into the return air of the high velocity unit for a simplified installation versus running that secondary duct system throughout the structure. And this particular diagram I'm showing right now is something I do upwards of 10,000 homes a year in the residential new construction industry, in that condominium or row housing type of market. I'm not sure if that type of build is popular in your area yet, but it is becoming the most popular type of build that I'm seeing throughout North America right now. And when it comes to a row housing solution, the builders are always looking to open up the floor plans, reduce mechanical walls, and this product gives them that type of solution, where with one 8-inch duct running the ceiling space of the main floor, feeding outlets to the second floor of the floor, and that of the ceiling into the main floor. It's a really simplified ducting solution, eliminating bulkheads and soffits from the structure. And a lot of these builders, I'm competing with somebody that's putting in a water heater and a furnace. And whether putting in a water heater and a furnace, that's 2 gas appliances you have to vent out of that application. This particular builder in my neck of the woods, we do 1,000 homes a year with, and they switched to us because of all the issues they were getting on coder compliance with the proximity of the gas venting of the high efficient furnace and the Navion. And we could go in there and use the same tankless water heater with my air handler, and you can see the difference from the gas furnace solution to the high velocity solution on the right, eliminating half of the gas venting requirement from that site. What I'm going to talk about now is more of the internals of our air handler, and these facts are congruent with my high velocity and low velocity line. For example, we can manufacture our products for 110 or 220 volt connections. Most of what we manufacture in stock today is 110 volt option. The 220 volt is always readily available and built to order. All of our units are zoning capable right out of the box with this very unique pressure modulating controller that is the heart of the way that we move air. We're doing things different with our motor blower combination that gives us the lowest watts per CFM in the worldwide air handler industry. And the heart of that is the fact that we're using a true variable frequency drive motor and control setup. It's not an ECM motor. It's using a WEG manufactured variable frequency drive to feed a 3-phase motor within my air handler. You don't connect me to 3-phase power. My air handler takes the 110 or 220, converts it to 3-phase for a much more economical electrical usage than traditional HVAC motors. Again, the lowest watts per CFM in the worldwide air handler industry right now because of this variable frequency drive solution. But it also does another unique setting where I utilize a pressure transducer and a pressure sensor within my board to measure supply air static pressure. Now, you have the ability to set my air handler at any static pressure operation. If you get an engineer that specified a 0.5 static low velocity duct system, try finding a first company fan coil that's going to operate at 0.5 static pressure consistently. My product, you can set it to 0.5 and it will always maintain that. As a filter starts getting dirty and restricted, it overcomes that by ramping up the voltage and frequency to maintain supply air static pressure. Now, what this does to simplify zoning is incredible. We have now the system that's sensing static pressure and maintaining it. So with my high velocity product, you set at 1 inch for cooling. Now you've got dampers. You shut off one damper, all that air wants to go out the remaining open zone. My sensor senses a change of static and will ramp that system back to the set static pressure. So whether you have 2 zones or 12 zones, the system automatically modulates itself eliminating the need to dump air or bypass air from zoning systems. It eliminates an incredible amount of the thought required on traditional zoning with air handlers in bypassing and dumping air by having this automatically modulating blower control. Now we have speed dials on our pressure sensing circuit board to adjust the cooling speed independent of the heating speed, independent of the constant fan speed. So you can set your DX cooling where it needs to be, your hydronic heating a little bit lower than that, and now you have the ability to set constant fan speed anywhere where the homeowner's comfort requirements are on that project. It's a really nice feature to promote to the end user. Running constant fan with this system will change the air quality within your structure, but also running constant fan with these systems will save you energy. Now all the gears spin in your head and say, running constant fan will save me energy. Makes no sense. I'm running a motor. It takes electricity to run a motor. It's going to cost me money. Yes, I'm going to get the air quality benefits by doing so, but you're on glue if you think I'm saving energy running constant fan on my furnace. Fan clip. With our product, because of how low the watt draw is on CFM on low constant speed operation, typically it's 50 to 60 watts of energy. It's the energy of a light bulb. But by running constant fan, you're not allowing that stratification of the air to occur when your fan stops. What actually happens is you're keeping your thermostat satisfied longer. By keeping your thermostat satisfied longer, your main energy consumers, your 1300 watt outdoor unit, your boiler system run less. And by running those appliances less, we've had independent tests in multiple places inform us that by running constant fan with our system, that 50 to 60 watts of energy, your thermostat stays satisfied longer, and you can save upwards of 20% on average energy by running constant fan with our products in conjunction with that MERV 13 filter and UV lights you put on your system to clean and purify the air 24/7 instead of 10 minutes out of the hour on intermittent heating and cooling calls. Now, we also are trying to make zoning simpler and easier with our product as well. We have now an integrated zoning air handler up to 4 zones where we at the factory install damper, Belimo actuator, and an EWC zone control and wire it up. So if you get one of our zoned air handlers out to site, the only thing you need to do is run an independent duct to each zone and bring a thermostat back to the air handler, and you just install the complete zoning system. No dumps, no bypasses. You don't have to think about any of that stuff. We're making zoning simple and easy and efficient. Now, I've talked about no bypasses and no dumps. In order to be able to truly eliminate a bypass from a zoning system, you do also need to use, at minimum, a 2-stage condenser. You can't put a single-stage condenser on a 3-zone air handler. You will freeze up, but we are doing 2-stage condensers up to 3 zones. In excess of 3 zones, we need to entertain chilled water or modulating refrigerant unit technology, which we do offer. And we do a lot of systems that exceed 4 zones. So with my integrated air handler with the dampers and zone control, we can do up to 4 zones. If you have an application where you need to exceed 4 zones, you can do a more traditional installation with dampers cutting off air to each zone, like shown in this application, which is becoming a very popular spec for us in commercial, providing independent climate control simply and easy with our high velocity zoned air handlers. We have done now up to 12 zones on a single 5-ton air handler, just to make you aware of it. Providing that independent climate control. But with that type of micro zoning, you do need to take a look at either chilled water or modulating outdoor unit technology. And we do now happy to offer our own inverter drive heat pump product. It's a side discharge unit for quiet operation and low footprint. It's rated down to -30 of operation, which makes us a perfect solution in northern climates for off-the-grid net zero energy solutions. This was instrumental in getting me into those 300 off-the-grid homes last year. I'm bringing it in a 2-ton, 3-ton, and 5-ton capacity range. Each of these heat pumps are able to operate down to 20% of their operational capacity. So now you have an air handler with zoning that automatically modulates itself. Combining that with an outdoor unit that mimics that modulation, you have the most simple and efficient zoning system available out there that really can change the game on how you install zoning and how you're offering the extra simple solution to your customers.
Tim,
In short, go ahead.
question, if you go back a slide, that -30 Fahrenheit, is that for heat pump or is that for cooling as well?
Well, it's specified for heating. What I can tell you is I did this very large indoor grow last year. And even in Edmonton, where I'm from, when it was -30, these rooms needed to cool and dehumidify. So I can now confirm my product works in -30 for cooling. Even though that's not what it was designed for, I have numerous applications where it has been.
Thank you.
That answer your question?
It did.
Perfect. One of our newest air handlers that we're now manufacturing in a mini style of application, we found this really unique blower technology called backward curve fan technology, and it is the future of my product line, as it's about 50% more efficient than my VFD option today. There are only 3 manufacturers in the world right now that manufacture this technology, and I'm dealing with all 3 of them. But we've developed a couple of very unique products. Our Cube series. The CU31 does 1-ton cooling, 30,000 BTUs heating. The CU51 does 2-ton cooling, 50,000 BTUs of heating, and what might be the most compact package to date of an air handler. Inside this air handler, we got that 6-row water coil or an electric strip solution. We can tie in one of our 1-ton or 2-ton cooling coils, either chilled water or DX refrigerant option. And I'm thinking about the tiny homes, condos, hotels. I've done garage heaters with this where I might just run an 8-inch duct with holes drilled into it, or non-ducted applications. One of my big production builders is putting this into every garage now as a garage heater, and it eliminates the need for them to run gas to the garage for a gas heater, where all they have to do is run a couple half-inch water lines off their boiler to get out to the garage to feed this in a non-ducted, more like a space heater application. Here's a 120-unit condo project we just finished up here, actually just a couple hours away from where I am right now in BC. And as you can see, this is a 2-ton, 50,000 BTU air handler in a tiny little cubby space above the laundry, where we were still able to fit in the Rinnai water heater as well as the heating solution to feed that air handler and a 2-ton. So very compact and very good solution for that condominium type of market. I've taken that same backward curve fan technology and instituted it into my 5-ton air handler in our HEP, our Platinum Series product line, getting into that net zero world where every watt counts against your solar production that you need to meet a net zero labeling. That 5-ton air handler option has been instrumental in getting me into those higher capacity, larger home net zero builds. But I've also instituted into a first of its kind, a 10-ton high velocity air handler that is exploding for me in the commercial development world, hallway pressurization, makeup air in high-rise buildings, but also indoor agricultural groves. In the last 2 years, this 10-ton air handler is my second most manufactured unit, and I'd say 80% of that went into indoor grow-op applications throughout North America. This was a chilled water dehumidification with hot water reheat solution. This was about 1 million square foot marijuana grow in Canada for Aurora Cannabis, where the dehumidification of our product was instrumental in getting us into this application. Here's another grow in Oakland, California, using my 10-ton air handlers in a non-ducted finish. Because the high humidity this grower wants to achieve, the duct would drip and cause an issue. So with our backward curved blower technology, we are approved for non-ducted applications. This particular 3,000 square foot rig you're looking at has 50 tons of high velocity AC and dehumidification in it. And even with 50 tons, due to the poor lights installed, it still has to run consistently to meet the requirements of that grower.
Hey Tim, just interject here. So there's actually a restaurant management company that later on this summer will be able to have one of these 10-ton units in a restaurant. There's a couple of them downtown that are slated to get this, and what they want to do is, a lot of those restaurants have those roll-up doors and those roll-up windows so they can be open air. The problem is they can't cool them once they decide to close them. You know, with the high velocity, they get a much faster cooling, and they're also able to just continue to keep it running, even though they're not really bringing down the temperature in these spaces. They're eliminating the humidity out of the bar areas, and they're really looking forward to, you know, if it's going to do everything we say it's going to do. It's going to keep the sweating down on the glasses. It's going to keep the floors from getting sticky and things like that when these restaurants are, you know, opening up, you know, that one wall of garage doors that they have. So hopefully in another couple of weeks we'll be seeing that install finished, and you know, then we'll have something right here on one of the larger commercial applications to see how it works.
Nice. And actually, like, it just brings up another thing that I've seen uniquely done now over the past 5 years is outdoor cooling. It sounds ridiculous, but the sushi restaurants in California and Florida will do an outdoor cooling solution. So it's a covered area, let's call it a deck for a restaurant, and we'll run a perimeter of plenum that's blowing down, and it creates like an air curtain thermal barrier that keeps the humidity out. It's keeping the bugs out. So I've done this in high-end residential, and a lot of restaurants recently is an outdoor type of cooling solution, which it just seems crazy to think about because they're not really cooling anything, but they find a huge difference in the comfort level of that space by keeping the humidity out with a thermal barrier. Last product I'm going to share with you today is, for me, it's just exploded my product line into applications worldwide I would have never had a sniff at just being high velocity. But our patented air purification system has been recognized by health sciences all over the world. We've sold product to NASA for the space station. This stuff is being utilized in very unique applications across the planet. And to date, it still is one of the most effective VOC removers out there in the worldwide date. So when you're putting in an effective air moving system like ours, it makes all the sense in the world to tie it into denser filter media, to take out the suspended particles in the air that you would regularly see when you open up the window and the sun shines in. Now, I'm compatible with any filter and any air purification system. If you have a product that you're utilizing and you've got those types of filters on your shelf and you want to keep that program, no bother for me. But I'm happy to share with you our own air purification system with 3 technologies in one cabinet to tackle all 3 classes of air contamination. Inside this one box starts with a MERV 13 filter, which is going to eradicate all particulates above 1 micron in size. And that is the stuff that you can see. That is the stuff that affects your asthma and allergies and the pet dander that exists within that home. And it's so amazing when I bring my laser particle counter out the site for a home that has run constant fan 24/7 with a denser filter. It's such a measurable difference of particulates in the air. And you almost can't even see them anymore when that sun shines in. So that's the stuff that you can see, you can smell. What's going to get past that MERV 13 filter is the stuff you can't see or smell. That's typically some sort of gaseous compound, microorganism, bacteria, or virus. Still today, the only FDA method approved to deactivate a virus is UVC deactivation. There's a lot of UVC products out there in the market right now, and you take your bulb and you put it into your ductwork, and they say it's going to do all this magic cleaning and killing. A UVC bulb outside of 3 inches loses over 90% of its emissivity and its killing power, which is why we've instituted 2 bulbs into our package with aluminum parabolic reflectors focusing the energy in one direction, so that we can expand that killing field to as large of an area as possible to help deactivate any viral contamination that might exist within your structure. Now, up until last year, I skipped by the virus conversation pretty quickly. It's very important now. It's in the focus and the forefront. But the real health benefits of this product is the titanium dioxide photocatalytic technology, of which we've obtained 7 patents on and have the best VOC gaseous compound removal on the planet to date. So what really is going to affect your quality and longevity of life is the stuff that you're breathing indoors every day, that off gas from the glues in your hardwood floors, the paints on your wall, the ceiling tiles, the PVC furnishings. As soon as that sun touches that, you're off-gassing hydrochlorobenzenes, formaldehydes, and cancer-causing chemicals into the air you breathe every day. And it's measurable in every single new home construction. And more measurable now than ever due to the tighter constructions of builds that we're doing today. We don't have natural infiltration, exfiltration occurring. And our answer in North America to VOC cancer-causing contamination is to dilute it through fresh air. We're going to bring fresh air in and dilute all of those cancer-causing contaminants into your home. We're really the only way to eradicate that from your indoor air is constant recirculation through some type of catalytic media, a VOC, and our patented media has been recognized worldwide as one of the best VOC reducers out there on the planet. So very passionate about, you have a system that's already able to mix and move air and clean it, combining that with denser filter media and air purification technology, in my opinion, very easy selling feature with this product and can really change the way the homeowner feels and the occupant feels within that space. I have all sorts of, this is actually a product that sometimes I do a 2-hour webinar just on it alone, showing all the numerous applications. I'll share with you one test. This was an independent test done by the Hong Kong Polytechnic University's Department of Indoor Air Quality, which showed VOCs are reduced by 80% in 2 hours, bacteria below the level of detection in 2.5 hours of runtime, and this was a completely independent test outside of our control. This was a picture I took from my iPhone November 2019 in Beijing, China. I didn't see the sun for 10 days out there. It is a nasty, I mean, fresh air in this type of area doesn't exist. That's a carbon particulate that you can smell in the air when you land out there, and it's scary stuff. The World Health Organization says that a PM 2.5 level above 70 is cancer causing. And they're typically talking about indoor air, but on this day in Beijing, the PM 2.5 level was at 126 outdoors. Very much cancer causing. Fresh air to bring in, no bueno. We did an installation in a hardware store, all sidewall delivery. During the 2-day installation, we were measuring a PM 2.5 level between 70 and 80 indoors. When we finally turned that system on, it took 1 hour to get it from cancer-causing 70 down to acceptable 10. And it took 2 full weeks of running to get it down to 1, 2, and maintain that. We do suggest changing that filter every 6 months and the lights once a year. The lights do not lose their illumination, but they do lose their emissivity and their killing power after a year of running 365, 24/7. We do sell those packages together with filters and lights or independently as well. Fairly economical replacement cost, somewhere in that $120 to $150 range if I had to guess. I have the exact same technology available in a standalone portable package as well, where you can plug it into the wall and do your main floor areas if you don't have the ability to add it to your current ducted solution. That is what I have for you today. I really appreciate you taking that time to join with us and hopefully learn a couple of things about our product and hopefully open up another tool into your tool belt that you can utilize. And if you have that really difficult to deal with project, get in touch with us. Jim there from Len Myers is an excellent representative of our product line. Provide him the plans for your project. He'll send them to us. We offer a free of charge engineering service for all of our customers. So in a 2-week time frame, you can get a fully engineered duct design for your project back from us at the factory that's completely submittable into your area to the best of my knowledge. And be happy to work with you. We're very easy to get a hold of. If you ever had a question from the conception of a project right to the commissioning, you pick up that phone and dial our 1-800 number and you will get somebody. Jim, can you contest? We're easy to get a hold of at the factory compared to some of your other manufacturers even?
Very easy.
Perfect.
It's, typical Canadian company, they actually answer the phone.
Tim,
That's what we did. Go ahead.
What's lead time on the equipment?
Right now, in the dead of summer, we're at a 2 to 3 week lead time.
Any problems getting it across the border?
At this point in time, never. No, actually, we've never had any. We do have our own stock. We have a consignment warehouse in Chicago and a consignment warehouse on the West Coast. So single system orders are typically able to ship within a very reasonable time frame out of Chicago. Multiple system orders, 2 to 3 weeks out of the factory.
Very good. Anybody else got any?
Any other questions, anybody?
No.
Tim, thanks for taking your vacation time.
It's my pleasure.
Appreciate it.
No problem. No problem. I thank you guys very much for tuning in today. And again, don't be afraid to pick up the phone and give us a call if you have anything you think we could help you out with. Utilize that free of charge engineering service and get a hold of us. So hopefully that you'll be interested to try this out on one of your future builds.
Very good.
Awesome.
Appreciate it.
Thank you, Tim. Have a great evening.
Thanks, guys. Cheers.
So that stuff's come a long ways, and
Yeah.
the last time I saw it, holy
Yeah.
cow.
Amazing.
And it didn't.
That's-
It looks a lot more promising than VRF.
That's the one thing that, high velocity really had to do, You have to look at, the change in the market, and when you have a better product that's basically losing its edge to easier product, you have to